Okay, today we're going to talk about gradualism versus punctuated equilibrium, and these are two theories or two ways that organisms change over time. If we look at the graphic here, you can pause it and just kind of annotate or pause, and if you want to draw it, you can. If we look at gradualism, we're going to notice that over time you see a slight change in the phenotype. Okay, you have um, a kind of a transitional phase here with these butterflies, in that it's going to diverge here, and speciation occurs in a over a long period of time where there are just small subtle changes. If we look at punctuated equilibrium, that's a different way that phenotypes can change and speciation can happen. And our Earth changes very slowly, but also our Earth can change suddenly. And so organisms that are living on the Earth, they're adapting to their environment, and sometimes environments can suddenly change. Punctuated equilibrium shows that sudden change. It shows the sudden adaptation of organisms and speciation. So when you're looking at punctuated equilibrium, there's no transitional phase. You have just a sudden change, and then you have periods where there's no change at all. But punctuated equilibrium indicates sudden evolution in response to a sudden change, and gradualism um, is something that is represented over a long period of time and just small, subtle changes. So, how does punctuated equilibrium happen? Well, you have a large population that experiences stability. Okay, it has stasis, enough food, shelter, and reproductive health. That it allows a slow, gradual change. Well, at some point, there's reproductive isolation, um, that whether geographically or whether um, sexually, there are barriers that prevent a, a small bit of the population from interbreeding with the large population. There's a lack of gene flow. And so a small section of the large population begins experiencing stasis. So um, when you have a small population, you have a sudden changes. You have genetic and morphological changes that happen quickly in small populations because they're isolated, and that goes back to genetic drift. Here in this diagram, you can see you have butterflies that went through a short evolutionary burst, and then they have the period of stasis, the period of stability. If we look at gradualism, we see that speciation occurs uniformly, it's steady, it's gradual, it's slow. You have transitional forms of the organism. It's more of a smooth and continuous process. Um, Big changes result over um, cumulative small changes over time. And so there's a constant evolutionary pace when we look at gradualism. The fossil record will have intermediate forms, or it will have transitional fossils that connect the ancestral species to that modern equivalent. Um, so we have a film that, and if we click on this icon, it will show and explain what's happening in this particular um, diagram. And it shows that large population going through stasis, then the isolation of the small population, and then again, that large population continuing to experience stability or stasis, while that small population is going through genetic drift. It is evolving rapidly. And then after that rapid change in the isolated population, there's a reintroduction of the small population into the larger population. Um, the population, there's expansion and stasis. So the snails that came out of the small population over that rapid evolutionary change, they begin, they're the directionally selected species, so they begin to survive and reproduce, and the smaller snails become ancestral. And so, what you have in the fossil record is you have the pattern of snail fossils where they all look the same, and then you have all of a sudden you have a punctuated pattern where those snails have been replaced by snails that are drastically different. And there you have the difference between punctuated equilibrium and gradualism.